Okay, this is section 4.5, solving logarithmic equations. So a logarithmic equation is one where the variable occurs inside a logarithm. So for example, log base 2 of x plus 2 equals 5 is a logarithmic equation because the x is inside the logarithm. And there's 4 steps we need in order to solve a log equation. Step 1 is to isolate the log term. Okay, so you should have, the log of some quantity on one side of the equal sign. Step 2 is you're going to write it in exponential form. So I'm sure you remember that log base A of x equals y means that a to the y is x. So you want to be able to convert back and forth in order to solve it. Step 3 is to solve for the variable. I'm just going to add a step, and that is to check your answer. And the reason I'm saying that is because you want to remember you cannot take the log of 0 or any negative. So sometimes you get answers that are not actually solutions to the problem, because when you put it back in, you end up trying to take the log of a negative. Okay, so let's look at a couple examples. All right, so the natural log of x equals 8. Okay, so step 1 is already done for us. The log is already isolated. Natural log of x equals 8. Step 2, you want to write this as an exponential function. Okay, so ln means log base e, so I can rewrite this as e to the 8th power equals x. Okay, and you're going to need your calculator for most of these because you're going to be estimating, and let's see, e to the 8th power is about 2,980.96. Okay, let's look at this one. Log base 2 of 25 minus x equals 3. Again, the log is already isolated for us, so we can go right to step 2, write this as an exponential function. So log base 2 means 2 to the 3rd power is equal to 25 minus x. 2 to the 3rd power is 8. Okay, and what are you going to subtract from 25 to equal 8? X has to equal 17. Right, and if you want, you can go back and check it. Log base 2 of 25 minus 17 equals, 3. And 25 minus 17 is 8. And we know that this is true. Log base 2 of 8 is 3. So it checks. All right, next up. This one's a little more complicated. My log is right here. I have 4 plus 3 times the log of 2x equals 16. All right, so step 1, isolate the log. All right, so I'm going to start by subtracting 4. So 3 times the log of 2x equals 12. Divide both sides by 3. And the log of 2x equals 4. Okay, remember that if it's just log, it's really base 10, right? So what this means is 10 to the, 10 to the 4th power equals 2x, right? 10 to the 4th power is 10,000. So if we just divide by 2, we find out that x equals 5,000. Okay, and if we want to go back and check it, we shouldn't have a problem with any negatives. Right, so this will be 10,000. So 4 plus 3 times the log of 10,000. The log of 10,000 is 4. 4 plus 3 times 4 4 plus 12 is 16, and it checks. All right, let's look at one more example. Okay, so this one is going to require us to remember our log rules where we can write, we can combine to write this as one logarithm, right? So the log of A plus the log of B is equal to the log of A times B. So I can combine these. To look like this. Okay, so I've isolated the log. I have one logarithm. Once I have one logarithm, I can write this in exponential form. So this is really log base 10. So 10 to the first power is equal to x plus 2 times x minus 1. I think you probably recognize that this is a quadratic. Whenever you have a quadratic, in order to solve it, you want to make one side equal to 0. All right, so we're going to multiply everything out here. So if I FOIL this, I get x squared plus 2x minus x will give me a positive x and minus 2. I want to make this side equal to 0. So I have 0 equals x squared plus x minus 12. This factors to x plus 4, x minus 3, and we end up with two answers, -4, +3. Now this is one where you want to be careful, right? If we substitute -4 back into either of these expressions, we'll end up taking the log of a negative, which we cannot do, right? The log of -4 plus 2 would be the log of -2, which you can't do, which means that's an extraneous root. 3 won't cause any problems. If you put 3 back in, we end up with the log of 5 plus the log of 2. And if you remember how to combine these, the log of A plus the log of B is equal to the log of A times B, right? So 5 times 2 is 10, and the log base 10 of 10 is 1. So this one checks, so we have one solution. All right, let's skip this one, and you can go ahead and try these 4. So these two are pretty straightforward. The log is already isolated. This one you need to get the log by itself before you can write it in exponential form. And then this one's like the one we just did. This one's a little challenging. You'll need to use some algebra to solve this one.